All right, we are going to go over this review for Chapter 1, Algebra 2, Chapter 1. This top three questions, there are three parts to it. It says they want us to tell whether it's a function or not, name the domain and range, and tell whether it's continuous, discrete, or neither. So each question, each problem is going to have three answers. All right, so if we look at this guy, first thing, we want to know if it's a function. We can do the vertical line test by drawing a vertical line through this, and if it only crosses the graph one time when you draw that line, it is a function. So as you can tell, when I drew the line, it only crossed once, so this is a function. Second question, name the domain and range. So your domain is your x values. So we come over here and we want to see when or what x values are involved in this graph. Well, this is going to keep on going forever and ever and ever down here, and as it goes down, it's also going out. So it's going to be negative infinity, and it goes all the way across, and then as I come over here, this guy goes up but out as well, so it's going to go to positive infinity. And then your range are all your y values, and again, it continues down and it continues up, and then there's no break in between. So it also is going to be negative infinity to positive infinity. Then we have to tell whether it's continuous, discrete, or neither. If I can start here and then draw it without picking up my pencil, it is continuous. So yes, this is continuous. All right, this guy is a function because, again, I can draw a vertical line through all these points and it never crosses another one of the points when I draw it. This one's close because it's right next to it, but it never crosses it. So this is a function. The difference with this guy is we have individual points instead of a steady graph, right? And so the domain of this is going to be the set of all x values of these points. So if we start over here, this guy is -3. 1, 2, 3, yep, -3. This guy is -2 x value. This guy has a +1 x value, a +2 x value, and a +5 x value. And then your domain, or excuse me, your range is going to be all the y values of the same points. So we'll start down here. We have -5. If we move up, there's one at 0 right there. We have two of them at x's or y is 1, and then we have one at y is 4. So that's the domain and the range. Then this type of a graph is discrete because it's just random points everywhere. So this guy is discrete. Then this one, the domain is going to be, because it's going up and on and out, up and out as it moves across x, right? So it's going to be, domain is going to be all real numbers, or you can write it as negative infinity to positive infinity. Okay? You don't really have to put the positive there if you don't want to. And then your range on this one, it doesn't, none of these values down here for y are involved in that graph. They don't start in becoming involved until -3 right there. So we put a bracket and -3, meaning that -3 is involved, okay, is part of it. And then it's every y value above that, so it's positive infinity with a parenthesis because you can't specify exact spot on infinity. Okay, it is a function. We skipped that part, I'm sorry, but if we do the vertical line test, when we draw a line, vertical line, it only crosses this graph one time. So it is a function. And the last thing is if it's continuous or discrete. I could start here and draw without picking up my pencil, so it is continuous. Okay? Down here, they want to know if which of these are linear. In order for an equation or a graph or whatever to be linear, a graph's super easy because you just look to see if it's a straight line. If it's a straight line, it's linear. If it's not straight, it's not linear. But if it's an equation like this, it has to be able to put into y equals mx plus b. X and y can't be multiplied together. X or y can't be in the denominator. and x or y cannot have exponents other than 1. So if those things match, then you're good to go. So for example, this guy, if I subtract 2x from both sides, it equals y. Y on this side equals negative 2x plus 10. So there's my y equals mx plus b. So this one is linear. Okay? This guy has an exponent of 2. You can't have an exponent other than 1, and 2 is obviously other than 1, so this is not linear. Over here, if you just look at it, that is not a straight line. That's got curve in it for sure, right there, right? So this is not linear. And when you look at a table, this the rate of change has to be the same throughout. So the x's all go up by the same amount, right? They all go up by 5, and then all the first 3 go up by 10,000. But then from here it goes down 10,000. It would need to be 80,000 here and 90,000 here in order for this to be linear. But because it drops back down, what's happening is you're going to have something that looks like this. Okay, as the x's go along, as we move along the x-axis, the y's go up and then they go down. So that is not linear. All right. This one, they want to know what type of symmetry they have. There's 2 types. There's line symmetry and there's point symmetry. Line symmetry is where we can draw a line and then fold the graph in half, and this half of the graph would fold on top of the other half of the graph. And that's what happens in this case. We have line symmetry at x equals -1. So line symmetry at x equals -1. Okay? In the middle, if you look, if I drew a line through here and folded it over, this guy this part right here would be down here, right? And it does, so it doesn't fall on top of this. So it has to match up completely for it to be line symmetry, and it doesn't. But if I put a point right there and I spin it around, so I spin this over here and I spin this over here, right? This is going to end up where that is, and that is going to end up where this is. So this would be considered point symmetry. All right, and it would be at, I mean, if they ask, it would be at point -1, -1, probably. Okay, and then here, this one is going to have line symmetry right here, because if I fold it over, this guy would fold right on top of that guy. And so this would be line symmetry at x equals -4. All right, so this next one, next section, they want you to give the x and y intercepts. So this is your x-axis, this is your y-axis, and they want to know where this graph intercepts those places. So right here and right here is where they're going to cross x. So your x-intercepts are going to be, one of them is going to be between x equals -1 and -2. So it's between -1 and -2. This little BN means between. And then there's another one over here that's between x equals 1 and 2. +1, +2. Okay, that's your x-intercept. Your y-intercept, I always do that. Your y-intercept is going to be this guy right here. Okay, and it's going to happen at x equals 0. They want the x values of where it happens. Okay, if you want to make it x is 0, -3, and make it a point, you can do that as well. That's fine. And that's exactly what's going to happen on number 12 here, because you're dealing with a chart. And the thing to keep in mind is that x-intercepts, right, your y value equals 0. Okay, so if you look here, my y value is 0 here. That means that this point is going to be my x-intercept. Okay, so my x-intercept is going to be 4, 0, because y is 0, right? And then my y-intercept, x equals 0. All right, So I look up here and, oh, look, there, x is 0 right there. So this point is my y-intercept, which is 0, 2. Okay? And that's it on that one. Over here, we have a y-intercept right here, and we have a y-intercept right there. And it looks to me like our x-intercept is right at 4. So that's 4, 0, or x equals 4 is fine. And then the y-intercept is going to be at y equals 3. 1, 2, 3. Yep, so that would be 0, 3, or y equals 3 is fine as well. Okay? On 14 through 16, they want the maximum and minimums or relative maximum and minimums. A maximum and a minimum means that's the highest that that graph goes. Absolutely. Okay? Relative means that we don't know exactly how, if there's a maximum or an actual maximum or an actual minimum, because the graph keeps on going and we only see a portion of it. So the relative maximum and minimum means for the portion that we're looking at, this is the highest point or this is the lowest point only in this section of the graph that we're dealing with. So first thing we're going to do is find just the x values, okay, of where their minimum and maximums are, or relative minimum and max. All right, so if we look at this, we have a minimum here, and a maximum there. Okay, and those are all relative because this keeps on going, so we don't know what's going to happen with this graph after this, but in this portion of the graph that we're looking at, here's our minimums, relative minimums, and here's our relative maximum, and they only want the x values. So we'll do the minimums first. Okay, so x equals, looks like -3, and x equals +1. And for our maximum, relative, these are both relative, our relative maximum is at x equals -1. It's not this number, it's this number. They want the x value right here. Okay? Then they want the end behavior. So remember, we write as x approaches -infinity, y approaches what? And as x approaches +infinity, y approaches what? And we fill these in. So as x goes this way, our y's are going up. So that's +infinity. As x approaches this or goes this way, y goes up, +infinity. Okay, over here we have a relative max here and a relative minimum there. So our minimum is going to be at, looks like it's between 0 and -1. So x is between, here, let's do this, sorry. Our minimum is between x equals 0 and -1. And our maximum is going to be between, oh, I did that backwards. I know all you guys at home are going, no, 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 that's wrong. Good for you. So there's max. That's our max right here between 0 and -1. Our minimum, relative, right, relative minimum, is over here between 1 and 2. So between x equals 1 and 2. Right? And your end behavior, as x approaches -infinity, y approaches, as we go this way, it goes down. So it's negative. And as x approaches +infinity, y approaches, so as we go this way, it's positive. Okay? All right, over here, we have a straight line, a linear equation, okay? And it continues on in both directions. So there are no min or max in this one. No relative, no reals, nothing. Just no minimum or maximum, okay? Because it keeps on going. But as x approaches -infinity, y approaches, it's going down, so -infinity. And as x approaches +infinity, y approaches +infinity. Because as we go this way, it's going up. Okay? Down here, they want us to find the end behavior of equations. The first thing you're going to need to do is find your degree and your leading coefficient. Your degree is the highest exponent, so it's 2 in this case. and your leading coefficient is the number in front of the variable associated with that highest exponent. So in this case, there's no number there, so it's assumed that it's 1. Okay? For degrees, we're looking for them to either be even, if you can see that, sorry. Either we're looking to see if they're even or odd. And for leading coefficient, we're wanting to know if they are positive or negative. Okay, and so in this case, we have even and we have positive. So if you look at the graph or the chart that I gave you, and you go to even and positive, it shows you that both end behaviors end like this. Okay, going up. Okay, so kind of like this. They both end up going up. Okay, so that means our end behavior is going to be the same as what this guy was. As x approaches negative infinity, y approaches positive infinity. And as x approaches infinity, y approaches infinity. Okay? Oops, sorry. There you go. Over here, we have a degree of 3. And our leading coefficient is -1. So that means we have odd and negative. So if you look at your chart, odd negative means it's going to end up as negative infinity. Ooh, it's going to end up like this. Okay, again, kind of like this guy but backwards. So it'd be more like it goes up over here and then comes down over here. Okay, but what that means is as x approaches negative infinity, y approaches positive infinity. And as x approaches infinity, y approaches negative infinity. Positive infinity, negative infinity. Okay? And then here, our degree is 2, and our leading coefficient is 1. So even and positive. Oops. Yep. Okay? So even and positive, that's the same thing as number 17. So as x approaches negative infinity, y approaches positive infinity. And as x approaches infinity, y also approaches infinity. All right, so this back page, they just want us to graph. And so when it has the equal sign, you're literally just graphing a line, okay? Especially because these are all linear, right? I don't have any squares or anything like that on it. So we need to get y alone. To do that, I'm going to add 4 to both sides. And by doing that, that gives me y equals -2x plus 4. This guy right here is our y-intercept, and this guy right here is our slope. So I start right here at my y-intercept. I go up 4, 1, 2, 3, 4, and I put a dot. And then I go to my slope, and it's -2, so I put it over 1, which means I'm going to go down 2, right 1. So down 2, right 1. Put a dot, and then I can draw my line. Maybe. There we go. Okay? Same thing over here. I just need to get y alone, so I'm going to add 2x to both sides. And that gives me y equals 2x minus 3. So I start at -3. This guy right here on the y-axis. Put a dot at -3. My slope is 2 over 1 this time instead of negative. So that means I'm going to go up 2 and right 1. And I can keep going up 2 and right 1 if I want to, as long as I want, or I could go down 2 and left 1.
Coach Howard's supposed to be here.
And over here, the difference between these is that we have the inequality sign, which means that if you recall, if you have less than or greater than, you're going to graph it with a dotted line. And if it's less than or equal to or greater than or equal to, it's a solid line. Okay, so we have a less than or equal to, so it's going to be a solid line on this one. But I need to move this x to the other side. That gives me y is less than or equal to -x plus 4. So again, we start with this, as our y-intercept. We put a dot at 4 on the y-axis. And then this time our slope has a negative x, so that means it is negative 1 over 1. So we're going to go down 1, right 1. Down 1, right 1. Connect our dots, and again, it's a solid lines because it's got the equal under it. Woo! Just like that. Then we look at this again, and if it's less than or equal to, we shade below. And greater than or equal to, we shade above. So this one's less than or equal to, so we're going to shade below. This guy, we just need to get rid of the 1, move it over here. That gives me y is greater than 2x minus 1. Now we're good to go. Start with our negative 1 on the y-axis, put a dot. Our slope is 2. We're going to put it over a 1, which means we're going to go positive 2 over 1. So we go up 2, right 1, up 2, right 1. And this one, notice it doesn't have the line under it, so it's a dotted line. Okay? So we draw dash, dotted, whatever you want to call it. Okay? And then we look and it's greater than, so that means we're going to shade above. So in this case, we're going to shade over here. Okay? What this means is that any point that's in this shaded area will satisfy this inequality. Meaning I could pick this number right here and take that x value, put it in for x, and its y value and put it in for y, and this would be a true statement. Okay? Over here, but it would not include the line. Okay, you could not pick a point on the line. Over here, it would be anything in this area, or since this is a solid line, you could pick a point on the line and it would work also. All right, x equals 2, x equals 2 right there, x also equals 2 right there, and there, and here, and there. So x equals 2 is a vertical line just like that. If it was y equals a number, it would be a horizontal line. Okay, and it's not an inequality, it's just a equal, so it's just a straight line. This one is an inequality, but its y is greater than negative 2. So y is negative 2 right here, and here, and here, and there. And it's got an equal sign on it, so it's a solid line, like that. And then it is greater than, so it's shaded above. So again, the answer or the thing that would make this a true statement is any point in this shaded area or on the line because it's solid.